Alright, welcome back. So this is the advanced section, and from what we started in the last time, we have a little test bench here and a little Jenga stack here, and we want to improve this to add some functionality, and we're going to be actually digging into the plugin now and use a little bit of blueprint, so make sure you're a little bit familiar with that, but we'll go over each and every step that's required. First thing we're going to do is just build a map, so we don't have to. I'm going to pop. Now that the map is built, we won't have any warnings on that. Alright, so how do we implement so that we can walk up to a block, say here. In fact, let's enlarge and look down. So, and then we try to grab it. So we need a way of detecting grabbing for one. And the other thing is we need to know, I guess, which hand does the grabbing. And then we need a way for the block to attach to the hand. And then we need another command to be able to release the block. So there are a couple of ways you can approach this. I'm just going to do one way. It may not be the best practice or anything like that, but it's a way that works. So the way we're going to do this is we're going to look at the plugin content first and find our character, which is this collision character. And just to have a little note of how this is all set up. The way the convenience content works is that all of the leap specific stuff comes from a leap controller and a event interface, which then is fed into a leap animation connector. And this, all of the characters contain this connector. If you want pass-through, then it contains all of the extra stuff. And then separately, the animation blueprint then takes the character, finds the animation body, and then maps it to the character animation blueprint. In this case, the collision branches off of the rigged character. And so we just want to take that branched character and make another subclass of it so we can do our Jenga specific things. So we're going to take this and create a blueprint based on it. And by default it creates it in the same folder, but we just want to keep everything in one location. So there we go. Let's rename this to Jenga character. And one thing we should do is change this to the Jenga character in the game mode. And if you hit play, you will notice it's still the same because we haven't changed anything. But now we can change all the things here and not really impact what we've done before. So inside the blueprint, in order to detect the grab, we could potentially add another leap controller, but for the purposes of this video, we won't need that because we're only interested in grabbing. And as it happens, the Leap Motion plugin actually has what shows up as gamepad events, but these are actually input mapping events. And so we don't actually need to add anything else, but just use the grab there. We have now two events that get fired every time we grab, and then so now all we need to do is something like print grab, and let's do this one as release. So these are input mapping events that get always emitted, and they're global, so you can include them in any blueprint. The caveat is that you need at least one leap controller somewhere, and because our character already is in the game, that is there. So we grab, we release, and this works for both hands, as you can tell. So we need this to do something. So obviously now we need some sort of collision, and the way we're going to do this is by making these not just static objects, static meshes, but we can add some functionality to this. We're just going to call these Jenga blocks. You can add any functionality by just going into the details and clicking blueprint. And we can create a blueprint out of this that contains the block. And as you can see, there's the block, and now we can add some stuff to it. So we want to be able to do some collision checks. And the way you do this is by going and clicking on your static mesh component, and if you scroll down in the details pane, you'll see something called event on component hit. And if we do that, we will get an event whenever this gets hit something. Now if you play this right now, this won't work because, as you see, they should be colliding with lots of other things and making events, but nothing's happening. The reason for this is, in order for this event to be called, you actually need to enable it. And make sure you select the block, you simulate it, the physics, and then a collision. Here we go. It says collision generates hits. And now this will spam because they're colliding all the time. So that's a good start, but now we need to just have an event that gets called whenever our hands collide with this. So one way to do this is to check that we're colliding with our character actor. Now we could potentially just take the other actor, cast it to the Jenga character we have, and if it's successful, collide. And then if we hit play, we walk up, you can see anytime I'm touching one of the blocks, I'm getting collide. But only for this one, because all of the other ones are not Jenga blocks. We can actually change that really quickly by just going into cube. Let's enlarge this for a little bit. There we go. So, cube mesh, cube. So all of these ones can be Jengas. And the way we do this is we just go right click on, we select them all, and then we replace it with a Jenga block. And this static mesh will change into Jenga blocks. And now, if we walk up to one of these, collide, collide, collide. Well, this is good, but this will only work if we have the Jenga character. If you want to be a little bit more robust, a little bit more, have one more level of indirection, we would create, let's put that in here, we would create an interface for this. And you'll see in a bit why. So we're just going to call this a pickup interface, or let's call it pickup character interface. And what's an interface? An interface is a bunch of functions that you can call on or add to classes, which they implement, and then you can always just check for the interface rather than specific classes. So you could, for example, have another class that has this same setup. In this case, we're just interested in one function, which is called pickup, and in there we're gonna just put in a static mesh actor called the object that we want this character to pick up, in this case being the Jenga block. And if we go in here in class settings, there's a little pane that says interfaces, and you can go pickup character interface, and you can see that we can now go pick up shows up when you right click. Before you do that, make sure you hit compile, and it's just a call. You want pickup event. Let's hit compile, and there's the pickup event. So what's going to happen is this is going to get called by the block whenever it collides, and we'll do some checks to see if we're going to be picking this up. So in here, in the Jenga block, now we can get rid of this hard bind to Jenga character and just go pick up cast to pick up interface. Does implement interface. There we go. And then we go pick up interface. Let's compile. Let's go pick up. There it is. Pick up character interface and branch. So what we're doing here is we are now checking if this class implements the interface, and only continuing if that is true. If that's true, then we can just call the interface function that we created, which was called pickup. So we are picking up, and what are we trying to pick up? Well, we're trying to pick up this. So we're just giving it a reference to ourselves. So whenever this gets hit, if it hits something that implements the interface, it will try to pick it up using our interface, and which calls this with that object. Now, we need to know if we're grabbing the moment that it gets called. So we're going to add a variable called grabbing, and we're going to set it from the interface, from the input mapping events that we defined earlier. Whenever we're grabbing, we're going to grab, and whenever we're not grabbing, that's no longer true. And that means that we can branch this off and go from the event pickup, and if that's true, then we can print trying to pick up. It's always good to do a sanity check before the complexity becomes too large. And if we walk over, nothing's happening as we're colliding, but if we're grabbing, you will see that we will try to pick it up only when grabbing. Alright, so the logic seems sound. Now all we have to do is two things. We should at this point create another function called which determines which hand should be picking this up. So now let's add the actual grabbing logic. So now we know that we're trying to pick this up. So we need to be able to pick up an object. How do we do that? Well, we get an object reference here. And if we drag it out and go, maybe we can attach it to something. There's an attach actor to actor, and there's an attach actor to component. We're going to use the component one because we have a component in here that is our mesh, which defines the whole body. And there's another one which is just the head. But this mesh actually contains all of the bones and where the hand is and all of that. So we're actually going to be attaching it to that mesh. So that's the parent, and the target is the object that we're trying to pick up. And for the purposes of right now, we're just going to attach it to the bone name hand R. Now, if you forget which hands or bones exist, then you can just go into our Leap Motion convenience content, and in character and basic, you will see a animation blueprint and a body. You can just click on any one of these and go into the skeleton, and you can see which bones are what. And so if we just, type in hand, we can see the right hand. And if we rotate it, we can see, okay, that's the hand. That's the left hand. So hand L and hand R are the bones that we want. And so in this case, we're attaching it to the hand R. Now, if we set this to keep relative offset, this won't work as we think it will. And so we just want to keep actually the world position when we do this. And we're going to weld it. Now, if we do this, every time it collides, and it'll collide every frame, it will attach it. So the first time that'll work, and then it's a little bit weird. So what we're going to do is we're actually going to create another variable called the pickup item, which is the item that we picked up, and we're going to make it a static mesh actor because that's the parent class of the Jenga block. So now that we have that item, we are going to check okay, one moment, we need to make some space here. So let's drag that out a bit. Okay, so why do we have this pointer? Well, the very first time this is going to be a reference to none. So what we're going to do is we're going to check, is that equal to none, which what that is, and we can just branch that. So when we're trying to pick up, if we don't have anything set, then attach it to the component and set it to none. If you don't have any references, that'll be none. Whoops. Drag off the object into the pickup item, and now you will set it, and you will only pick it up once. Let's try that. Let's try and see if we've forgotten something, or so here we go. We're gonna go up, and whoop, look at that. We've attached a block. Okay, it's kind of cool. We can pop against other things, and but yeah, I can't get rid of it, and it's kind of weird. Feels like something is stuck in my hand, even though I know nothing is. Oh well. So, pickup, success. Now we need to release it. But before we do that, there's something to be said about keeping a clean setup. So we're going to add a function here that's actually going to be called pickup if empty. And all we're doing is we're taking all of this logic and we are putting it and attaching it to this function so that we hide all of our logic into simple functions. Static mesh actor, and then object compile, and we see up, and there's the target, and one more, which is to set the reference. There. Now we can pick up and then just drag that, and as you can see, our basic event graph is still pretty clean from that. Now, before we do the release, I want to show you one more thing that we need to do, which is if we walk up, we might be able to pick up with this one, but what if we, use our left hand instead? And if we go ahead and grab, oh, what happened? It's not attached to my left hand. And that's because it will always attach to the right hand, no matter what. So we need to know which hand we should attach it to first. As you can see, we attach to the right hand. The way we're going to do this is we need to figure out where we're colliding. In order to do that, we need to change our interface a little bit and add one more input, which is a hit result. Actually, we just want the location, so we go location. And if we go in here, we have the hit here, and we're going to break that result from the Jenga block, from when the component hits, and we're going to grab the location. And we need to compile this so that we get that new variable to show up, and we just connect the location. And now we're going to get the hit location. Now, you might ask why. And that's because we now have the location here. And pickup if empty should actually have another one which just says location. And we can pass that through to our function. Okay, now that we have location where we need it to be, we can use this to create another function which is called closest hand. And we're going to take that location and we're going to return the name of the bone that we need to attach our block to. So this is our global location, and so we will need to get our capsule component, get location, and we need to attach that to the bone location, which is also called a socket. So we're going to check for two of our sockets, and we're going to get the length between these two. So this is the world location. We subtract out the local location of the bone, and we get a vector, and we just need a length, and we can copy all of this. Yeah, let's just copy all of it and do that for the right hand as well, and compare the distances between the two. So in this case, the left hand. So if the actually, let's swap these two. So we're comparing the right hand to the left hand. So if it's greater, if the right hand is farther away, then so I'm just swap these, because if the left hand is smaller than the right hand, then it's closer to the left hand, and so we want a name, make a literal name, up, hand L, and hand R. And we need a local variable called bone name to set this name to, and drag that out. So if it's if the right is smaller than the left, then we have the right arm, and we set that. And then let's default if they're the same to left hand to keep things simple. And drag out down the arrow, drag that to the final, and get a reference to the bone name there. So now this function will give you the closest hand to the location. Nope, it won't. Ah. Yeah. We don't need that. We need the location. That should be a world location anyway. Yeah. Mistakes are made. And there we go. Now that should give you the closest hand. So we have pickup if empty, and now we need to know which bone to attach it to, and the way that we do it is we just drag out this function and go, hey, which one is the closest hand to that location that we just got from the hit result? Oh, it's this bone. And now if we play, we will be able to attach to the left hand as well. But it's still stuck to the hand. How annoying is that? Let's fix that. So, how do we release it? Well, we already have a function to release, which is right here. We stop grabbing. In fact, that's really what we're going to do. We're going to release whatever object we have in pickup by detaching it. Detach from parent or detach from actor. Detach from actor. So, when we stop grabbing, we're going to detach the pickup item. But there is a problem here. The pickup item might not exist, so we need to actually do a check for that. And to do that, we just compare it to an empty object and branch it. So if it's not equal to 0, so false, then we can detach it. And then the final thing is we need to now clear off the reference to that pickup item so that we have an empty hand again, and we go, hey, we just drop that object. Dropped. Alright, let's give it a shot. So now we pick up an object. Oh, it's really close to the sensor, so it's sometimes a little bit hard to actually see this in action. Hold on. Yeah, in fact, let's just make this movable so I don't have to recompile. And yeah, let's move this up a bit. Make my life a little bit easier for this purposes. That doesn't work. Alright, let's see if this works. So we walk up. And it's behaving a bit weirdly. Need to make sure the execution node is connected. Alright, so now have the block attached. Okay. So let's link everything up again. So now when we're not grabbing and we have an item already picked up, then we're going to detach it and clear the pickup item and just let us know in blueprint that we did that. There we go. We have a block and I dropped it. But physics stopped. Now why is that? Well, when we attached it, we changed some of the characteristics. So the final thing we need to do is actually, before we clear out the pickup item, we need to physics. Simulate physics, and now we need to set that to true. So after we've detached it, we re-enable physics simulation, and all should be well in this world. Let's give it a shot. Now we pick up an item, we drop it. Oh, look at that. We can walk up and pick it up with the left hand and drop it. And launch ourselves into space, because obviously that's something we do. Let's try that in VR. So to try it in VR, all we have to do is go into play options, VR preview. And I'm just going to line it up so you can see this better. And just give me a second. Alright, and now we're in VR mode. So I'm still using WASD, but I can go up and pick up a block, drop it, and we can use our fingers to sort of move some things around. And let's see if we can't grab this block. We can, carefully. Oh. Let's try that again. Oh. It's a bit jittery. It's a bit hard to pick up a block, because this essentially, once it's attached to your hand, it behaves like a kinematic physics part. So, you know, it ignores mass, all of those things. But, yeah. And with that, we finish part 2. We can go in, move some blocks, and we can go in, pick up a block, drop it, and all is good in the world. But we can't pick up blocks on the ground. They're just simply too far away. Even in virtual reality, we just have no way of reaching down on blocks down below. And since we're going to be in virtual reality, we might as well use something cool like, how about telekinesis? Stay for part 3 to find out how to do that.